Okay, so I will explain something about the research method. So this is to avoid many mistakes that I and many other people have made. Okay, so this is okay. So these are a random collection of thought with some divisions and lists, and they are from experiences and are practical. So one of the fundamental questions is that our activity must be seen as productive and positively and fruitfully contributing to society. So to be supported by the society in large. So of course, no money is free. Okay. So how can we do mathematical research more efficiently so that we can be seen as more productive by the society? So we are actually behind many areas in terms of perception. So we cannot say that applied mathematics helps. So applied mathematics is often already practiced extensively by some engineering people. So we should so provide the method and tool to apply the mathematician. I'm saying these applied mathematicians, these engineers as well. Okay, so we should provide some good tools. Of course, there could be other answers. So also I will say something about future trends. So pure mathematics will diversify more and more. Of course, applied mathematics will diversify even more than us. And there will be less and less central themes as before. So since the foundations were more or less settled in 1970s, we need to concentrate on developing more tools and apply the theories to deeper levels. So also we may use more and more computers, so we might be putting more and more mathematical results into systematized precise codes and links. So as a lesser example, so he was a developer of LaTeX and was a recent Turing Award winner. So he says there should be some sort of computer coded and links of all the mathematical results. This should make the results much more precise and less erroneous. I think that there are full of errors in modern literature in mathematics. So some parts of set theory and logic is already in good cause, but not all of the mathematics, of course. Also, you may use some automatic proof checkers. So there are these things. Currently, the technology is quite primitive, so it's not that useful for us right now. But it could develop. Also, much more tools of computation could be used for pure mathematics and vice versa. Some are rigorous and some are not rigorous, and I think there is no real clear divisions among them, so that's kind of unfortunate. But I mean, I think there are some good algorithms which are rigorous, as long as under the assumption that it's working correctly as the program is intended. So there might be much more pressure for pure mathematics to be applicable. For us, graphics used in games and animations pose some opportunities since they lack efficiency at a great scales, and there seem to be many problems unsolved by computer engineers without the knowledge of geometry and topology, so we must exploit these weaknesses, but I'm not sure that we are doing that right now. But, so these are just thoughts about my future trend and and also about what the goal of mathematics is. So let's talk about research as a research method. So first of all, research is a cooperation. So research should be done by dividing into many parts. So it's very difficult to do this by just alone. So you need to formulate a good chunk where one can formulate good questions that could be answerable or near answerable, and then parcel out these chunks to other people so that other people can make a progress also. So when we started, so like in 40 years ago, it was more or less much more individualistic work, but recently that has changed. So so we should also have good relationship with foreign researchers because we are still lagging behind them in large sense. So one can do very similar research as long as directions and aims are different. So with the foreign and the national researchers, I guess. Also, the proofs that are different can be published as well. One should not try to directly compete with them since they can hamper your advances. However, this is not to say one should avoid all complex here. So I give some explanation of how research moves in general, particularly in this field related to ours. So there will be busy activities after some breakthroughs by some particular good approaches and or technical materials. However, there might be too much competition then, and your research are not so spectacular among them. So one gets exhausted soon in this way. So anyway, it is okay as long as you have own techniques and perspective and so on, and as long as you can use your own strengths in this particular area. So some research method, let's talk about that. So we make some plausible conjectures and we develop theory and examples so we can test out our complete understanding. So constructing concrete examples are always fruitful. So without examples, one can also make big mistakes. There is of course no ideal foolproof way to do mathematics rigorously without testing out against examples. Okay, so this is a mistake, and it is more like software development than the mathematicians admit. Many details areas have interesting problems, and conjectures are not often so clear due to our lack of precision in understanding the example. So we need to understand examples. Okay, so then so we need to build examples and then theory building, and these things should cycle. So if you just start with the theory building, it will often get to be quite weird and not very progressive. So also another thing is to build our own expertise and not rely on foreign sources or other people. So must have some strong advantage over some particular areas. So otherwise you don't have any leverages. So you need to have some particular area, strengths in some particular area to have leverages. So we need to have some workshop to test out ideas among people. However, they don't always tell you the truth. So sometimes similar work is okay, but if one can find differences, however, it might be tearing. So we have to find some source of research that others are not working on with too many people. So we need to build our own special programs. And okay. So also we need to keep learn new areas. So one must constantly learn new areas to be productive. So what you learn during the graduate school are not open enough, and there will be many new developments. So one must choose what to learn for future research and so on. One can spend huge amount of time and effort without any research gain, so this could be dangerous. So one must have some strong areas of learning so that you have some advantage over other researchers and can compete well because of that. So the focus should be slightly off from other researchers, because if it's too much the same, then it's just going to be too much competition. So actively learning and researching on the subject could be the best way to learn. So for example, one can even rewrite old papers with modern perspective. And then in that way you can learn about the subject. Okay. So also writing well is also a good research method. Finding a good way to explain is a research purpose as well. So it's one of the research purposes as well. So I don't think that research is finished until we have a good writing, at least in pure mathematics. So during the research, one should write things well. Also, memory often fails often, so we often don't know what you did after some time. So you need to write well when you have ideas. Otherwise, it's going to be no help. So use OneNote, for example. I have forgotten lots of ideas which seemed very good at the time because I didn't write it down. Okay. Also, there will be more and more technological aid. So join something like the ResearchGate or Google Scholar. It will allow you to relay this research sometimes correctly, and you use Google search and math sign where so they will give you lots of things in fact freely. And AI might develop further to be more helpful in mathematics. So please watch out for good AI tools in research. I think these are already very useful in other areas of science, but I'm not completely sure about the pure mathematics. So anyway, so these are some helpful books, but I do recommend reading Primer of Mathematical Writing. So this is not about research, but it's still very helpful. And Steven Krantz wrote the Proof is in the Pudding. So he wrote some history of the proofs in modern mathematics. But I do disagree with some of his conclusions. But this is a very helpful book. Hadamard wrote The Mathematician's Mind. So this is on how to become a creative mathematician. And this is, I really recommend it if you can find this book. I have a copy. So also Henry Poincaré wrote this book called Science and Methods. So he has some deep philosophy on how to do science and research. But I'm not sure if it's really that well adapted to today's method.